All right, so now we're going to talk about section 2.3 from Math 171 about division of polynomials, the remainder theorem, and the factor theorem. If you remember from, math, from the first math courses you took, you'll notice I've got an equation over here. And I've got what I did in this problem was I took 81. I just want to see how many times does 3 go into 81. So the way we do that, 3 goes into 8 twice. 2 times 3 is 6. Subtract. 8 minus 6 is 2. The result of that subtraction should be less than the divisor. It is. 3 doesn't go into 2, so I bring down the 1. 3 goes into 21 7 times. So what are these parts of division? Well, what's under the root is called the dividend. What I'm dividing by is called the divisor. And the result of division is the quotient. So here is the translation. If 3 goes into 81 27 times, then 3 times 27 equals 81. That's just a quick overview of long division, and then how can we use it to help us, right? So over here on the problem, I don't have numbers, I have polynomials. Can I do this? Can I do division with polynomials? Absolutely. We talked about it in 2.2. We talked about it in 2.1 with the algebra of functions. Yes, you can divide them, but you have to do it with long division in the same process you just saw. So let's tackle this first problem here. I've got x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 18 divided by x squared minus 3. And first thing I have to do is I need to make sure every power of x is represented. Even if there's no term there that has that power of x, I need to put it in there as a placeholder. So my dividend has an x to the 5th, has an x to the 4th term, has an x cubed term. It does not have an x squared term. So I'm going to add that plus 0x squared in. It has an x term, and it has a constant term. And I'm supposed to divide that by, my divisor has an x squared term. It does not have an x term, but it does have a constant term. So there's the problem written out. Now we're going to do long division to figure out what's the quotient of taking x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 18 and dividing it by x squared minus 3. So the write-up is going to look exactly the same as our long division from before. The divisor is out front. The dividend is under the division. Minus 8x plus 18. And I start there. Now, this process is a little complicated. The way that we did a problem before, or the way that we did this long division up above, as I said, 3 goes into 8 how many times, right? So it was okay that the divisor doesn't have to go into the first digit perfectly. For long division with polynomials, it does. So what that means is when I start this problem, I take the leading term of my divisor, and I take the leading term of my dividend, and I figure out what happens if I divide these? What do I need to multiply x squared by to get x to the fifth? Well, it's easy. Just take x to the fifth and divide it by x squared. What do I get? I get x cubed. Okay? X cubed is in my quotient. And notice that these terms are, see how that's lining up over the cubed terms? Make sure you do that as you go. So now what do? Well, I take that x cubed, I multiply by x squared, I get x to the fifth. I did it right because these match, okay? This is what is determining if you did it right. It's all about, does the leading term of the divisor go into the leading term of the dividend? And does it go into it perfectly? The answer is yes. So now I'm going to take x cubed, and I'm going to multiply it by the divisor. What do I get? X squared plus 0x minus 3. Distribute that, and that's x to the fifth times, distribute x cubed times 0x is 0x to the fourth, and x cubed times negative 3 is negative 3x cubed. So, yes, I did hold on to this, even though I know x cubed times 0x is 0. I'm only holding on to this so that I'm lining up my power here, my x to the fourth. Okay, even though the coefficient is 0 and I know it's not really there, what I don't want to happen is if I don't write that, someone is going to do this. And now the powers don't line up, and this can't be subtracted because they're not like. So that's the reason you see me doing, probably like jumping through some hoops to hold on to something that is definitely 0. Minus 3x cubed. In long division, this is always subtraction. X to the fifth minus x to the fifth is nothing. Negative 2x to the fourth minus nothing is negative 2x to the fourth. And x cubed minus negative 3x cubed is plus 3x cubed. X cubed plus 3x cubed, 4x cubed. And now it is rinse and repeat, and just continue doing it. I've got two terms here. I need a third, so I bring down the x squared term, even though it's a 0. And now what do? I do the same step I did before. Here's the new leading term, negative 2x to the fourth. I divide it by the leading term of the divisor, which is x squared. And I find out that the division gives me negative 2x squared. X to the fourth divided by x squared. Dividing with the same base, you subtract the powers. 4 minus 2 is 2. All right, so now that I have that, I write that in my quotient. Again, making sure to line it up over the powers. And now I multiply the negative 2x squared times the divisor. X squared plus 0x minus 3. Distribute. And again, I am going to hold on to that 0 place. Let's get rid of that equal sign over here. Negative 2x squared times x squared is negative 2x to the fourth. Negative 2x squared times 0x. X squared plus x would give me an x cubed. But we know it's a 0 for the coefficient. And then lastly, negative 2x squared times negative 3 is positive 6x squared. So I did that. So there's my next line. I want to show you that what I just did there is the same thing as the long division that you're used to. Negative 2x squared times x squared is negative 2x to the fourth. Negative 2x squared times 0x is 0x cubed. Negative 2x squared times negative 3 is 6x x squared. Subtract negative 2x to the fourth minus negative 2x to the fourth is 0. We did it right. 4x cubed minus 0x cubed is 4x cubed. 0x squared minus 6x squared is negative 6x squared. Okay. So minus, oh, what did I do there? Oh, there we go. 0, 0. All right. So what do? We do it again. Bring down the next term. And I once again take the new leading term, 4x cubed. I divide it by the leading term of the divisor. That leaves me with 4x. Now I'm going to do this. I'm not going to write this multiplication out like I have been doing. I'm going to follow it the way we've been doing it, the way I just did it or showed it to you. X cubed times, what am I doing? X cubed. 4x, that's the term I'm after. 4x times x squared, 4x cubed. Those match. I did it right. 4x times 0x is 0x squared. 4x times negative 3 is negative 12x. This is subtraction. 4x cubed minus 4x cubed is 0. Negative 6x squared minus 0x squared is negative 6x squared. And negative 8x minus negative 12x becomes plus. So that becomes plus 4x. And then the last step, bring down that 18. Let's get rid of this little bit right here. Make sure you see that's something separate. And what do? I take that new leading term, which is negative 6x squared. I divide that by x squared. 6x squared divided by x squared is just negative 6. So that's the last factor, that's the last term in my quotient. And now we just do the math like we've been doing the whole time. Negative 6 times x squared. Negative 6x squared. That's what we wanted to happen. Negative 6 times 0x is 0x. Negative 6 times negative 3 is positive 18. Subtract. And I find negative 6x squared minus negative 6x squared is 0. 4x minus 0x is 4x. 18 minus 18 is 0. And I'm done. All right. So my quotient is x cubed minus 2x squared plus 4x minus 6. I have my divisor over here, x squared plus 0x minus 3. I have my dividend under the division. And then I have, you remember this term, the remainder. All right. So what does all of this mean? What does all of this work mean? Okay. Well, remember in my previous problem, or my simple long division problem, 3 went into 21 7 times 3 is 21. Subtract everything, the remainder is 0. That means that 3 goes into 81 perfectly. Same idea here. Does x squared plus 0x minus 3 go into x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 18 evenly? No, it does not, because the remainder is non-zero. 0. Now, previously we said that when I get done with the problem, I can rewrite the dividend as the product of the divisor and the quotient. When I have a remainder, I have to add that to the right-hand side. So what I said was that when I get done with these, the dividend is equal to the quotient times the divisor plus the remainder. Okay, we're dealing with polynomials. So what we're going to have is, instead of having just numbers here, we're going to have a polynomial. So each one of these is going to be a function. So the dividend is typically represented by p of x because we start out with that polynomial. The quotient is represented by q. The divisor is represented by lowercase d. And then the remainder is represented by capital R of x. So what have I done? Well, the dividend from this problem, the original problem, was x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 18. That's p of x. That is equal to the quotient. What did we find the quotient to be? X cubed minus 2x squared plus 4x minus 6. X cubed minus 2x squared plus 4x minus 6. So there's the quotient. And then the divisor was what I divided by, which was x squared minus 3. And then plus, and what's the remainder? The remainder is 4x. And this is the result. I now know that the polynomial p can be rewritten as q times d plus r. All right, so that's one page down. That is 18 minutes in. So these problems do take time. Please respect them and don't think you can do all of this work in just the last 4 or 5 hours before an assignment is due. It is not going to go well for you. So we're going to do the same thing, different problem. My divisor is not squared this time. That's going to make life a little easier because my divisor only has 2 terms. My dividend only has 3 terms, but it's missing one. So I have an x cubed, I have an x squared, I don't have an x term. Divided by, and then the divisor is just x minus 5. All right, so set it up. What do I have? X minus 5 divided into 2x cubed minus 7x squared plus 0x minus 65. All right, so, and we go. Leading term of the divisor, leading term of the dividend. 2x cubed divided by x equals 2x squared. 2x squared times x gives me 2x cubed. Remember, this is what's controlling what terms you put in the quotient. It's this first subtraction has to zero out. So we can see it this way, take the leading term of the dividend, take the leading term of the divisor and divide them, or you can say, what do I need to multiply x by to get 2x cubed? I need 2x squared. I did it, so I did that, and then I need to continue or finish out this multiplication. 2x squared times x is 2x cubed. 2x squared times negative 5x is times negative 5 is negative 10x squared. Subtract 2x cubed minus 2x cubed is 0. That's what I wanted. 7x squared minus negative 10x squared becomes plus 10x squared. Negative 7x squared plus 10x squared. It's 3x squared. I only have one term now. Bring down the next. And rinse and repeat. 3x squared divided by x is 3x. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Subtract. 3x squared minus 3x squared is 0. We knew that was going to happen. 0x minus negative 15x is plus. That's a really good reason, a really good example of why leaving or why putting in that last, keeping those 0 x's or 0 whatever terms there are. This is the reason you do it, because if you didn't have this 0 here, it would look like it's just negative 15, but it's not. It's minus negative 15. Bring down the last term, and then do it again. 15x divided by x is 15. 15 times x is 15x. 15 times negative 5 is negative 65. Subtract. 15x minus 15x is 0. Negative 65 minus negative 65 becomes plus 65, which is 0. I have a remainder of 0, which means x to the 5th goes into 2x cubed minus 7x squared plus 0x minus 65. If I want to write it out, p of x is equal to the quotient times the divisor plus the remainder. The original p of x is 2x cubed minus 7x squared plus, I'm not going to write the plus 0x here. That's more a thing for making sure long division lines up. Minus 65 is equal to the quotient, 2x squared plus 3x. Plus 15? Yeah, plus 15. Times the divisor. And the divisor was x minus 5. And the remainder is 0. Now, why would I teach you long division? What's the purpose or the point? Well, look at this problem. This problem started out with a third-degree polynomial. We have not learned how to factor all third-degree polynomials. But by doing long division and finding that I can rewrite this cubic as this quadratic times this linear, but times this line, times this binomial, I can factor this now, right? I can factor 2x squared plus 3x plus 15 because I know how to do it because it's a quadratic. So that's one reason we want to, it's very important to learn about division because now I can take higher order polynomials, break them down until they become quadratics or linear, and then I can find all of the solutions. And now we got one more example to deal with for long division. And we got, so 4x cubed minus 23x plus 3 divided by x squared minus 5. Are we missing any terms in either the dividend or the divisor? Yes. Yes, we are. So that is 4x cubed. I don't have an x squared term. Minus 23x plus 3 divided by 2x minus 5. So write it up, get it into that long division form. 4x cubed plus 0x squared minus 23x plus 3. I'm going to try to do a more color-coded example here. So leading term, and tell you what, let's make the divisor red. That might help. 2x minus 5. So leading term of the dividend, leading term of the divisor, and divide them. And what do I get? 4x cubed divided by 2x is 2x squared. So 2x squared is the first term in my quotient. Line the powers up. Do not put 2x squared here. Put it over the other x squared terms. And then I take that 2x squared and I multiply it by 2x minus 5. And I get what? 2x squared times 2x is 4x cubed. 2x squared times negative 5 is negative 10x squared. That step right there is the same step as me saying 2x squared times 2x is 4x cubed. 2x squared minus times negative 5 is negative 10x squared. Okay. Subtract. 4x cubed minus 4x cubed is 0, exactly. 0x squared minus negative 10x squared becomes plus 10x squared. So plus gives me positive 10x squared. Bring down the next term. And then we start the process over. Here's my new leading term. What do I need to multiply 10x, what do I need to multiply 2x by to get 10x squared? Or what is the quotient of 10x squared divided by 2x? Both of those get you the same result. 10 divided by 2 is 5. X squared divided by x is x. So there's 5x. 5x times 2x is 10x squared. 5x times negative 5 is negative 25x. Subtract. 10x squared minus 10x squared is 0, exactly like we want it to do. Negative 23x minus negative 25. Minus negative 25 is plus, so negative 23x plus 25x leaves me 2x. I've got one more term left in my divisor, and that is, in my dividend, and that is the 3. 2x goes into 2x. How many times? 2x divided by 2x. Super boring? Yeah, because that is 1. So plus 1. And now let's find what happens. 1 times 2x is 2x. 1 times negative 5 is negative 5. Subtract. 2x minus 2x is 0. 3 minus negative 5 is 8. All right. So I told you the original setup for when we do these problems. I am going to switch one little piece on the previous example, I put the q of x and then the divisor d of x. I'm actually going to write it the other way because it's going to help out later. And then plus r of x. It doesn't matter because d of x times q of x is the same thing as q of x times d of x. But it's a whole lot easier if you write that, the divisor. It's usually going to be a much lower order polynomial. So it's easier to write that first. So my original divisor, or excuse me, my original polynomial, 4x cubed minus 23x plus 3 can be rewritten as the divisor was 2x minus 5. The quotient is 2x squared plus 5x plus 1. And then this one has a remainder, and that remainder is 8. All right, so a little bit of color coordination going on here. If you find that helpful, let me know, because that's definitely something that I can easily focus my time on, or focus more time on. So now that everybody has seen long division and everybody is regretting taking Math 171 real quick because it's taken us 30 minutes to do 3 problems, I'm going to show you there's an easier way to work these problems. And that easier way is through use of synthetic division. All right? Now, you can use synthetic division when the divisor has variable to the first power with a coefficient of 1. So what I mean by that is 2x squared minus 6x plus 4 divided by x minus 3. Yes, there's my divisor is x minus 3. X is to the first power, and it has a coefficient of 1. If I write that same problem, but I do 2x minus 3 instead, I can't use it. I can't use it because that 2 is there, and if I tried to divide by x squared minus 3, I'm not allowed to do that either because x has to be to the first power with a coefficient of 1. All right, so once we've met those requirements, we're going to set the problem up. To set the problem up, you solve your divisor. You determine what value for x would make the divisor equal 0. So step 1, x minus 5 is equal to 0, leads me to x is 5. All right? So if x is 5, and because what am I after here? I want to see how many times does x minus 5 go into 2x cubed minus 7x squared minus 65. So I take that 5, and I'm going to put it in this little half box. And then out beside that, I'm going to put the coefficients of all of the terms of the divisor. Now, just like before, do I have all of the terms? Do I have a term for each power of x, starting with x cubed and going down? I have the x cubed, I have the x squared. I don't have something to the x power. So my problem is really as such. Okay? 2x cubed minus 7x squared plus 0x minus 65. So I'm going to take all of those coefficients and I'm going to write them off to the right of the box where I got the 5. So first coefficient is a 2. Next coefficient is negative 7. Next coefficient is 0. And then the last is negative 65. All right. So I've set up the problem using synthetic division. This is the second part. Okay. The first thing that happens is the leading coefficient gets brought down and is part of the new quotient. Okay? Once that process begins, pull down that leading coefficient, and now I'm going to take my, take the 5 over here in the box. I'm going to multiply it by whatever the rightmost number is in my quotient down here, which is a 2. And I'm going to get that 5 times 2 is 10. And always, 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 when I'm dealing with synthetic division, I add. So negative 7 plus 10 is 3. 5 times 3 is 15. 0 plus 15 is 15. 5 times 15 is 65. Negative 65 plus 65 is 0. Okay? What in the world did we just do? Well, what we found is those red numbers along the bottom are the coefficients for the powers of x in descending order. My original problem, notice I'm taking a cubic, I'm dividing by a linear, so a third degree divided by a first degree. 3 minus 1 is 2. So this 2 is the coefficient of the x squared term. All right, I started out, I've got a cubic divided by a linear. So when I get done, I expect to have a quadratic or second degree. So if that 2 is for x squared, then that 3 is for the power of x, is for x to the power, first power, and then the last one is, then 15 is the constant. But wait a second, there's another number out here. Yes, there is. And that number is the remainder. All right, so that's r of x. We did this problem, I think we did this problem. I think this is a repeat. Yeah, we did this problem already, right? But look at how quickly I was able to get it done. And now, what do I get to do with all this information? I'm just going to write p of x. No. Let's be consistent. Let's make sure everybody knows what's going on. My original problem, 2x cubed minus 7x squared minus 65 is equal to the divisor, which is x minus 5, times the quotient, 2x squared plus 3x plus 15 plus the remainder, which is 0. So we don't have to write that, but there it is anyway. Much easier to deal with. Would everybody agree with that? Yeah, I'm going to speak for you. And yes, you all agree that is way, 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 way easier. So let's do another one. I happen to have an example right here. So I've got 2x to the 5th plus 13x to the 4th minus 3x cubed minus 58x squared minus 20x plus 24 over x minus 2. Notice for the first time, my highest power in the numerator is a 5, and every term, every power of x shows up in one of the terms in the numerator, right? X to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, and then the constant. So I don't have to add anything else in or make sure I've got a 0 as a placeholder. That first step, take your divisor, set it equal to 0 and solve. And then that is the number that goes into the little box. Coefficients are 2, 13, negative 3, negative 58, negative 20, and 24. Step 1, bring down the 2. Step 2, 2 times 2 is 4, and then we add 13 plus 4 is 17. 2 times 17 is 34. Add negative 3 plus 34 is 31. 31 times 2 is 62. Negative 58 plus 62 is 4. 4 times 2 is 8. Negative 20 plus 8 is negative 12. Negative 12 times 2, negative 24. 24 plus negative 24 is 0. Now, when you do these, I didn't do it for the first one, but remember that last number from your synthetic division is the remainder. So a lot of times you'll see where they put a little dotted line, and that divides up what the red numbers are the quotient, and then the green numbers, or the green number is the remainder. So what did I find? Okay, well, what is the quotient here? So remember that 2 is going to be whatever the degree of the dividend is, divided by that leading degree of the divisor. 2x to the 5th divided by x, that's going to leave me x to the 4th, right? So this 2 is the coefficient for x to the 4th. That 17 is the coefficient for x to the 3rd. And we're just going to go down in descending order. X squared, x's, and then constant. And now I can rewrite the original as what? The original for that problem is very long. Let's see if we can try to find it over here. Nope. Okay. So the original, we could actually, I don't need to scroll up. It's all written right here if we can read it correctly, right? These numbers in black across the top, those are the coefficients of the original dividend. So that 2 corresponded to an x to the 5th, the 13 an x to the 4th, the negative 3 an x cubed, the negative 58 is an x squared, negative 20, and then 24 is equal to the divisor, which was x minus 2 times the quotient. And the quotient is 2x to the 4th plus 17x cubed plus 31x squared plus 4x minus 12 plus the remainder, which is 0. All right. Last one on this page. One more problem to do. And what have they done here? Well, they gave us the polynomials, but they're not in descending order. My dividend actually has a cubic as the second term and a square as the first term. Always make sure that you rewrite your divisor and dividend in descending order before you set up a synthetic division problem. Because if you're not careful, you might put the first as negative 10, and then the next is 2, and the next is negative 5. Well, if you do that, synthetic division thinks, or it's going to be working on the assumption that the number you're dividing into is negative 10x cubed plus 2x squared. So rewrite highest power first, and then descend from there, 10x squared. I don't have an x term, but I still need to represent it for a placeholder. And set it up. X plus 1, take the divisor, find the solution. That goes in the box. And then coefficients of the dividend. 2x cubed minus 10x squared plus 0x minus 5. Bring the 2 down. Negative 1 times 2 is negative 2. Add those. Negative 10 plus negative 2 is negative 12. Negative 12. Ooh, that's not in red, Larry. Come on now. Negative 12. Negative 12 times negative 1 is 12. 0 plus 12 is 12. Negative 1 times 12 is negative 12. Negative 5 plus negative 12 is negative 17. And then let me change that color. We would typically, right, we're splitting that up to that's my quotient, those are the coefficients of my quotient, and then that last one is my remainder. So what is the quotient? Well, this was a x cubed problem. So drop that by 1 degree, and I'm looking at x squares. So that 2 is the coefficient of the x squared term. That negative 12 is the coefficient of the x. And that 12 is a 12. And then the remainder is negative 17. So that means that the original problem, 2x cubed minus 10x squared minus 5, is equal to the divisor, which was x minus, x plus 1, times the quotient, 2x squared minus 12x plus 12 plus the remainder of negative 17, which just becomes minus 17. So there is synthetic division and, well, long division and synthetic division with multiple examples.